For about 200,000 years, Neanderthals thrived in Eurasia. They were skilled hunters, used fire, and had complex tools. Yet, around 40,000 years ago, they vanished, leaving only traces in our DNA. What happened to these close relatives? The answer might be a complex puzzle with multiple pieces. This essay explores 5 possible factors that could have driven Neanderthals to extinction. Competition with Homo sapiens, interbreeding, climate change, disease, and the challenges of small, isolated populations. These were not primitive beings, they were intelligent hominids who survived challenging ice ages. Their disappearance raises intriguing questions about our own species' success and the factors that can doom even the most resilient species. By exploring the possible causes of their disappearance, we gain valuable insights into the forces that have shaped human evolution and continue to shape our planet's biodiversity. Around the time Neanderthals began to disappear, Homo sapiens, our direct ancestors, were spreading across Europe and Asia. Did these new arrivals contribute to Neanderthal extinction? It's possible that competition for resources played a role. Homo sapiens, with their more diverse tools and possibly more sophisticated hunting strategies, may have outcompeted Neanderthals for essential resources like food and shelter. Imagine a landscape where both species hunted the same prey, sought refuge in the same caves, and relied on the same dwindling resources during harsh winters. In such a scenario, even a slight advantage for one species could have tipped the scales, leading to the decline of the other. Neanderthals, more reliant on large game, may have been more vulnerable to environmental changes that affected their primary food sources. It's more probable that the cumulative effects of competition for resources, combined with other factors, gradually pushed Neanderthals towards extinction. We know that Homo sapiens and Neanderthals interbred, as evidenced by the presence of Neanderthal DNA in modern human populations. But did this interbreeding contribute to their extinction, or was it a sign of peaceful coexistence? It's likely a complex mix of both. On one hand, interbreeding could have led to the absorption of Neanderthals into Homo sapiens populations, effectively diluting their gene pool over time. This doesn't necessarily mean a violent takeover. It could have been a gradual process of cultural and genetic assimilation, with mixed offspring becoming more integrated into Homo sapiens groups. The complex dynamics of interbreeding, with its potential for both genetic assimilation and vulnerability, remain an area of active research. The period leading up to the Neanderthal extinction was marked by dramatic climate change, including periods of extreme cold and rapid warming. These fluctuations likely placed significant stress on Neanderthal populations, who were already facing competition from Homo sapiens and potentially suffering from low genetic diversity. Neanderthals, adapted for colder climates, might have struggled to adjust to rapid warming periods, which could have altered their hunting grounds and disrupted their food sources. Climate change could have also fragmented Neanderthal populations, pushing them into isolated pockets across Europe and Asia. In such circumstances, even small differences in adaptability or resourcefulness could have given Homo sapiens a significant advantage, leading to the gradual displacement of Neanderthals from their ecological niches. Another possible factor in the Neanderthal extinction is disease. While evidence is limited, it's plausible that diseases carried by Homo sapiens, or to which Neanderthals had limited immunity, could have ravaged their populations. Neanderthals, with their smaller populations and potentially lower genetic diversity, might have been particularly susceptible to new diseases. Their immune systems, adapted to different pathogens, might have been ill-equipped to handle the introduction of novel diseases carried by migrating Homo sapiens populations. Furthermore, the stress of climate change, competition for resources, and potential interbreeding could have weakened Neanderthal immune systems, making them even more vulnerable to disease outbreaks. The possibility of disease, particularly in conjunction with other stressors, remains a plausible contributor to their demise. Finally, the size and structure of Neanderthal populations likely played a role in their extinction. Evidence suggests that Neanderthals lived in smaller, more scattered groups than Homo sapiens. Smaller groups are more vulnerable to random events, such as disease outbreaks, famines, or natural disasters. Furthermore, smaller populations have less genetic diversity, making them less adaptable to changing environments and more susceptible to inbreeding. This lack of genetic diversity could have compounded the negative effects of climate change, disease, and competition with Homo sapiens. The combination of small, fragmented populations with low genetic diversity likely created a perfect storm for Neanderthals, making them highly susceptible to extinction when faced with multiple environmental and social pressures.